What is a process? The programming execution is nothing but a process. It is a time required by the process to complete the execution. It is also called as running time. What are jobs? It is a type of program without any kind of user interaction. Priority scheduling is a method of scheduling process based on some priority. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Students, in this session, we are going to talk about the chapter 3, that is CPU scheduling algorithm in operating system. So, this is the agenda, this is the topic to be covered here, CPU scheduling. Now, let us see what is the definition of CPU scheduling. So, you know CPU I'm talking about a processor. So, CPU scheduling is a process of determining which process will own CPU for execution while another process is on hold. So, this is I'm talking about multiprocessor system. So, if there are, you know what is a process? The programming execution is nothing but a process. So, if there are more than one process is running, so then it is what scheduling is the process of determining which process will get the CPU time for execution while another is on hold. So, this is the concept of CPU scheduling. So, here the main task of scheduling is to make sure that whenever the CPU remains idle, the OS at least select one of the processes available in the ready queue. So we know that all the processes will be in a ready queue for execution. So those are the processes waiting for CPU time for execution. So the main task, purpose of CPU scheduling is to keep the CPU busy continuously. So if at all if it remains idle, then actually the operating system, it select one of the process from the ready queue for execution. Now, the selection process will be carried out by the CPU scheduler. So, it select one of the process in memory that are ready for execution. So, it's going to select one of the process from the ready queue for execution. So, this is the concept of CPU scheduling. Now, in the next slide, we will see what are all different types of CPU scheduling. So, as we have seen in the previous session, one is preemptive scheduling, second one is non-preemptive scheduling. Now, what is preemptive scheduling here? So, here the tasks are mostly assigned with their priorities, and sometimes it is important to run a task with higher priority before another lower priority task, even if the lower priority task is still running. So this is the definition of preemptive scheduling. So the concept here is, so in preemptive scheduling, the processor, it executes the process which are on higher priority, and sometimes even though the priority, whichever the task is running or the process is running, and it allow the another processor with higher priority for execution. So the lower priority task holds for some time and resumes when higher priority task finishes its execution. So this is the concept of preemptive scheduling, where it is going to execute the process which are in higher priority even though other processes are running. So other process which have the lower priority will resume its process or execution after completion of higher priority process. Now, in non-preemptive scheduling, another type of scheduling, non-preemptive scheduling, here the CPU has been allocated to a specific process. The process that keeps the CPU busy will release the CPU either by switching context or terminating. And it's the only method that can be used for various hardware platform. So here the meaning here is, here the process that keeps the CPU busy, it will be released or terminated either by switching context or by terminating. See, what is the meaning of switching context here? That is, context switching is nothing but if there are more than one process running or executing, so the CPU or time, it is going to move from one context to another context. That is the concept of switching context. So, example for this, the process switching from running to the waiting state. As we have seen in the previous session, we have the process state. So, running state to waiting state, this is the content switch again, and process finished its execution and terminated. See, these two are the example for non-preemptive scheduling. Next one is important scheduling terminologies. Let us see different terms we use with respect to CPU scheduling. One is burst time or execution time. So, it is a time required by the process to complete the execution. It is also called as running time. So, what is a burst time or execution time? It is the process, it takes its time for completion, for completing its execution. That is the burst time. Next, arrival time. What is arrival time? When a process enters in a ready state. So, here we know what is the ready queue. The process to be executed will be the ready queue. So, that once it enters the ready state, means it's supposed to start execution. Finish time, when the process complete and exit from the system. The CPU is going to release the process from the processor. That is the finishing time. Multiprogramming. So, multiprogramming, a number of programs which can be present in a memory at the same time. So, the multiprogramming concept here, generally more than one program will be in the computer memory for the program to be executed. So, these are the different terms to be used in CPU scheduling. Next one is jobs. What are jobs? It is a type of program without any kind of user interaction. It is nothing but a program or a type of program where the user cannot interact with the operating system or with the program until it completes the task or until it completes the instruction in a particular job. That is the concept of the job. Then user, it is a kind of program having user interaction, and process, reference that it is used for both jobs and user. And CPU or I/O burst cycle. Here, characterize process execution which alternates between CPU and I/O activity. CPU times are usually shorter than I/O time. So, these are all other different terms again. Next, we'll look into that. What are different types of CPU scheduling? Here, there are mainly 6 types. One is FCFS, first come, first serve. It is scheduling algorithm. SJF, shortest job first scheduling, shortest remaining time, priority scheduling, round robin scheduling, multi-level queue scheduling. These are all different types of CPU scheduling. Now let us see the definition of first come, first serve algorithm scheduling. So here, as the process enters the ready queue, its PCB, we have seen the process control block, is linked with the tail of the queue. So when the CPU becomes free, it should be assigned to the process at the beginning of the queue. So this is the first come, first serve basis, in the sense, say whichever the process will enter the ready queue first, that will be executed, and with the help of this PCB. So here PCB will be assigned to this particular task or particular process. This is first come, first serve scheduling algorithm. And what are the characteristics of this? So here it offers non-preemptive and preemptive scheduling algorithm. Then jobs are always executed on a first come, first serve basis, easy to implement and use, and it is poor in performance and wait time is quite high. So these are the characteristics of FCFS method. Next one is shortest remaining time. The full form is of SRT is shortest remaining time. It's an algorithm. It is also known as SJF, primitive scheduling. In this method, the process will be allocated to the task which is closer to its completion. In other words, we can say, the process which takes very less time for completion, its execution. So those type of process will be given priority. That is the meaning of shortest remaining time scheduling algorithm. What are the characteristics of this? This method is mostly applied in batch processing environment where short jobs are required to be given preference. This is one application or characteristics, and it is ideal method for implement in a shared system. In a shared system where the required CPU time is unknown. Another characteristics, and it associates with each process as the length of next CPU burst. We know what is the burst. We have learned in the previous slide. The definition of burst means the time taken for the completion. So that the operating system uses this length, which helps to schedule the process with shortest possible time. So these are the characteristics of SRT, shortest time remaining. Next concept is, or next scheduling is priority-based scheduling. So priority scheduling is a method of scheduling process based on some priority. So in this method, the scheduler selects the task based on the priority. That is scheduler. The process with the higher priority should be carried out first, whereas jobs with the equal priorities are carried out on the round robin or FCFS basis. So this is the priority basis. So generally, this is the priority is set based on CPU time or processor time, so by considering other factors. So based on the priority, process will be executed from the ready queue. This is priority based scheduling. Next one is round robin scheduling. So this is the oldest method of algorithm or CPU scheduling algorithm, and it mostly used for scheduling algorithm in multitasking approaches. Generally, round robin algorithm, here all the process will get its time for execution. That is the concept of round robin scheduling. And here it is a hybrid model which is a clock driven. And time slice should be minimum, which is assigned for a specific task to be processed. However, it may vary from different processes. So the time slice means the time taken for the process to be completed, executed. It is a real-time system which responds to the event within a specific time limit. See, these are all the characteristics of round-robin scheduling algorithm. Generally, in round-robin algorithm, all the process will be getting its own time for execution. Next one is shortest job first. As we have seen in the previous slide, shortest time remaining, another name for this. So here it is shortest job first is a scheduling algorithm which the process with the shortest execution of time will be selected for execution. So, and this is what are the characteristics of this. It associated with each job has a unit of time to complete. So it will be known, so it should be known to us. Each job will be having, or a process will be having its own time for process to be completed. And in this method, when CPU is available, when the CPU is idle or CPU time is available, the next process or job with the shortest completion time will be executed. So that is the concept here. And the algorithm method is used for batch type processing. So it's a batch type processing where waiting for job to complete is not critical. It improves the job output by offering shortest jobs, and which should be executed first, which mostly have a shortest turnaround time. So generally, what is shortest job first means? It is the algorithm where the process which will be having a lesser completion time, or it takes very minimum time for completing its process, those type of process will be executed in the queue. That is the concept of shortest job first. In the next slide, multiple level queues scheduling. So here, this algorithm separates a ready queue into various separate queues. Okay, in this method, the process are assigned to a queue based on priority of the process. And like the process priority, size of the memory, etc. By considering different parameters or different characteristics, it will be given priority. So this is not an independent scheduling OS algorithm, as it needs to use other types of algorithm in order to schedule the job. So this is the multiple level algorithm or multiple level queue scheduling. Let us see characteristics of multiple level queue scheduling. Here it should be maintained for process with some characteristics, and every queue may have its separate scheduling algorithms, and priorities are given for each queue. What you have seen in the previous slide, that in the ready queue, inside this we have different separate queues will be created. So based on that, it is going to have a separate queue, and each queue will be having its own scheduling algorithm. So this is the concept of multiple level queues scheduling. In the next slide, multiprocessor scheduling. It is a multiprocessor scheduling. So here it is a system that has more than one processor but shares the same memory bus and input and output devices. So this is the concept of multiprocessor operating system or scheduling. If I talk about multiprocessor, so we have more than one processor in a computer system, and both the processor will share the same memory and same bus and I/O devices. In multiprocessor scheduling, more than one processor or CPU share the load to handle the execution of processes smoothly. So here, if there is only single processor system or only one processor in a system or one CPU, so one CPU is responsible for completing or executing more than one process in a system. But if there are more than one processor, so here both the processors or number of processors will handle the more than one process and is going to balance the workload of CPU. That is the concept of multiprocessor scheduling. And the scheduling process of multiprocessor is more complex than that of single processor system. And multiple CPU in the system share a common bus, memory, and other I/O devices. So this is the concept of multiprocessor scheduling algorithm. Next here, under multiple processor scheduling, there are two approaches. One is asymmetric multiprocessing, and here when all the scheduling decisions and I/O processing are handled by a single processor, which is called the master server, and other processor execute only the user code. So this is a simple and reduce the need of data sharing. So this is asymmetric multiprocessing. It is one approach under multiprocessor scheduling, where here there are two concepts. One processor is called master server, and another one is called a user. Another processor will execute the user code. So this is the concept of asymmetric multiprocessing. Another approach is symmetric multiprocessing, where each processor is a self-scheduling, and all processes may be in a common ready queue, or each processor may have its own private queue for ready processes. See, this is another concept here. The scheduling proceeds further by having the scheduler for each processor examine the ready queue and select the process for execution. See, this is the concept of symmetric multiprocessing scheduling. Students, so far we have discussed about CPU scheduling, types of CPU scheduling algorithms. So, in the next session, we will discuss chapter 1 under unit 2. Thank you very much.